Okay, Ayushi, thanks so much for asking this question. I really appreciate it. I love questions. Section 5.4, practice question 2B. 2B, which wants us to use the component method. So we can do that. And we're setting up our directions here. X hat is east, Y hat is north. We know the mass of the student in this question. We know the mass of the cart. We know their velocities right here. Velocity student, velocity cart. They're the same because they're moving together. This is before the walking of the student occurs. Then the student starts to walk, and this becomes the net velocity of the student, as if you were watching it from the floor. Okay, when someone's watching it from the floor, this is the velocity that we see. Actually, all of these velocities are relative to the floor. What do we have to find out? Well, we want to see what the velocity of the cart is after or as the student is walking. That's the prime now. That's the question mark. Prime as the student is walking, no prime before the student was walking. So we break it down into components, x and y. There's what we do. So we have to have conservation of momentum, x components conservation. So we do that. So hopefully we realize that before the walking occurred, there was no x component. The cart and the student were solely moving along the y-axis. So this is 0. And that would have to equal the momentum of the student as they're walking, x component, plus the momentum of the cart as the student is walking, x component. And then we expand that by using the equation for momentum, which we know is mass times velocity. And that's what we've done here. We've expanded them with the known expression. Then what we do is we bring this first term here over to the other side. It becomes negative. Then we divide both sides by the mass of the cart. So it cancels out on this side. And we plug in some numbers and we do some great stuff with our handy dandy fancy dancy calculator. And here is the x component of the cart's velocity as the student is walking. There you have it. So that's the x component. The y component, similarly, if we know that the momentum is conserved, it is conserved in the y direction as well. So what does y component of the momentum look like before the walking occurs? Well, it's made up of the student's momentum before walking y component plus the cart's momentum before the walking y component. And similarly on this side, it's the student's momentum as they're walking y component plus the cart's momentum as the student is walking y component. But if you take a look at the velocity of the student as they're walking, it's completely west, negative x hat. So there's no y component here. It's gone, 0. There's no y component to the velocity. Bingo, bango, it's gone. So what we do is we divide both sides by mass of the cart. And we plug in our numbers. We use our handy dandy fancy dancy calculator to do some supercalifragilistic calculations. And there is the y component of the velocity. Thank you so much for asking this question. I really appreciate it. And you have a great day. Bye bye.